so as mentioned, I'm Jeff Weiss. I'm a senior staff backend engineer at Adobe. It's a lot of words to say I'm old, and I've been doing Elixir for a long time. So I'm going to talk about what we're doing on the search subsystem of Adobe's product, Frame.io. So just a bit about our agenda for this talk. I'm going to talk about the goals, so what you should get out of the talk. I'm going to set some context. We'll talk about what we're doing for video semantic search embeddings. So as videos come in, we ingest them and put things in our search index. How we're also using AI for natural language search for getting results out of the search index. And I'll talk about our lessons learned, and then we'll go into some Q&A at the end. So when you leave, I want you to have a few concrete strategies on how you can integrate LLMs into your applications, and then what you need to do to keep it going past that initial implementation. And you should also be able to walk away with an understanding of why, in this particular case, we chose Broadway to do our ingest for semantic embeddings over our default for async work, which is Oban. So we're using Oban a lot for many things, but Broadway was a better fit for this case. So a bit of context. Frame.io started as a video review and approval platform, primarily for film editors, and has grown into a collaboration platform for all creative work that's in progress. So we help creatives share, review, comment on, organize a variety of assets used for digital production. So this isn't a Frame.io sales pitch, so I'll leave it there. But in short, we handle a ton of videos and images. The features that I'm discussing are enabled for about 2.5 million of our customer accounts on version 4 of our product. That's not the entire population across version 4 or a version 3 product, but it's enough to be meaningful. The customers who experience the most benefit from these features are the ones that have in the tens of thousands or even large enterprise accounts into the millions of assets. So the use case that I think about this is if you're a film editor who works on Marvel films and you have tons of scenes from past, because Marvel loves to do flashbacks. You may have a scene that you need to pull into a new video, and you need to search the giant back catalog to find the specific scene that you're looking for, whether it's tagged with specific metadata or you're looking for contents in the scene. We have about 20 terabytes in our current search index cluster. That's across several indexes, dozens of hosts, and hundreds of shards. We maintain some headroom there too because we need to do a migration between search indexes, and we need to do those live as our schema evolves. Also, like around the schema evolution, as we get feedback from customers, we need to add new metadata fields, we need to index different kinds of data, and we need to be able to seamlessly migrate from one search index and its schema to a new one as it comes online. And so that requires us to do forward fill writes to both the production index and to the pending index while we're backfilling the pending index with the old data as well. So an example of this is that we recently launched transcription search support across a bunch of different locales. And so as we were enabling the new locales for, say, like Japanese, we needed to write to our existing production index while we ingested those new transcriptions. So I'll start with the semantic embeddings portion of search. So this is how we get videos in, clip them into what's going on in the scene, and then store those into the index. And then we'll talk about how we get things out of the index in a little while. So after a customer uploads a video, this is our normal process on Frame. We transcode the video that comes in so that we have consistent codecs and resolution sizes. That helps customers view and comment with smaller versions of the asset. So for instance, if you upload an 8K video, that's going to be a gargantuan file that may make it difficult for customers to view and comment on. So you may get a 720p version of the video for the web. Your editor might work with the 1080p for the rough cut. But I broke the remote. Great. But we also have search-specific transcodes that we generate to help optimize that. Because the embeddings do take a long time, we also do the fan out to our multiple search indexes that I talked about. We have the video transcription, so on the text side, content of what's discussed and occurring in the video as well. That doesn't have near the volume or complexity as the visual content, and so I'm going to I'll focus primarily on the visual content because it's the more interesting use case. So our upstream embedding model is from Adobe Research. You'll sometimes hear me refer to it as like search cut because that's what's been ingrained in my brain. That's the internal name for it. But that's an internal model that's not trained on customer data. So that's a benefit that we're able to give to our enterprise customers if they know as we're processing their videos, we're not going to like train the model on their proprietary content. This process of doing semantic embeddings works if you're doing a commercial model as well, like a 12 Labs or something like that. So you provide a visual resource, and you get back a list of floats or a list of lists of floats for what's in your scenes. Our default choice at Frame is for async work is Oban. However, like our Oban job management database is also our operational database. And given that we're doing this for every new asset that's uploaded by 2.5 million accounts, that's a lot of, like, that's a non-trivial increase into our database traffic, and our provisioned RDS instance is already strained. So given that we control neither the input video complexity or that upstream model, we're at the mercy of long tail operations. And we need some back pressure so that we can parallelize that work for the different customers coming in and not block head of line. So one of the tests that I had in our beta is I saw the embeddings took 45 minutes. I was looking at our dashboard. I came in the morning and it's like, oh no, one of them took like 45 minutes to encode. Like something's wrong. I thought my code was broken. I looked at all of the logs to track down the time when that happened. It turned out there were a lot of videos that were encoded during that 45 minutes. I wish I'd had the Datadog MCP to help me track it down. It didn't exist at that time. But after I found it, I realized that like it was a 6-hour video that a customer uploaded like of a rave. It was just like raw content that they had uploaded, a 6-hour rave, and it took 45 minutes to encode. And so that's the kind of problems that we're dealing with. We don't have any control over what customers upload. So our internal API for search cut is CQRS style. So like we submit a job, we get a job handle, and then we query and poll like, is that job done? No, okay, I'll go to sleep. Is it done? No, I'll go to sleep. So our worker did that for 45 minutes, just like every second. Hey, are you done? Nope, okay, I'll go back to sleep. So fortunately, like it did the work. It just took a long time. Recently, we had another video that took 8 hours to generate the embeddings for. This happens, but fortunately, like I don't have to care if it is like a really long or complex video or if maybe our upstream service is degraded and this is just back pressure that we see. So between like, we're using Kafka for some things, we could have used GenStage or Flow or done this manually. We had a handful of options for how to handle embeddings as they come in. We opted to go with Broadway and SQS. We already had this pattern in other places of our code, so it made provisioning the indexes and queues across all of our environments fairly trivial. We have 3 distinct pipelines. So we have a router that comes in that handles authorization and that index schema fan out. And then we have specific pipelines for the semantic embeddings and for the transcription text processing. And one of my key concerns here was we need to inject the signal to start these operations in other parts of our code base where customers are waiting. And so whether that's on the transcode generation or on the transcription processing. And so I wanted it to be as quick as possible to get that signal out to start our process and not have any collateral damage if there's an error, like trying to create an Oban job or something like that if our database is backed up. So the media transcode pipeline now looks like this. There are other aspects for a bunch of different like transcodes that we do and how we store them out to object stores, et cetera. But this is what's necessary from my standpoint for search. The video transcription, so the text-based is similar. It's not just on the video side for different resolutions. There's similar things for the text as well, whether that's like SRT or VTT. There's specific formats for like subtitles in films. So we get the signal, we need to do something, get it out as quick as possible, and then move on. So we've got a fairly basic Broadway setup for our router pipeline, and again, this is the one that does the authorization and fan out to different indexes. And the thing to note here is we've got just different batchers for our downstream Broadway pipelines. So that first round, Broadway pipeline looks at the customer account. Are they authorized for semantic embeddings, or have they opted out? Some customers are concerned that we may still want to train on their data, and so they opt out. So then we do the authorization and the fan out to other indexes, and then we create SQS messages for those other downstream Broadway pipelines. This allows us, for the different indexes in here, so that if we have new models that come online that we want to integrate, so for instance, one that does face recognition in addition to scene recognition, we're able to do this at this layer, and then our downstream embedding pipeline can focus just on its specific needs. So here, like the router pipeline is figuring out what indexes to write to before it sends it downstream. And those downstream ones don't need to do any business logic around whether a customer's authorized. They just focus on what they need to do and where it's stored. So the embedding pipeline then looks like this. So we'll generate model-specific payload, send that off to our service, maybe wait a long time, and then once we're given embeddings, we store them out into OpenSearch. And we do some batching for our writes to OpenSearch, which you can see here. So one of the things that we've done in our embedding pipeline is we've separated like the core Broadway workflow from the model-specific things that we need to do for versions. So in this case, we look up, hey, what's my handler for this specific index schema, and then process it in there. We're also doing some timing because instrumentation is key. And then in the second example, we're writing out all of those embeddings as a batch to OpenSearch. Okay, so our embeddings are in the search index. Like, now what? How do we get them out or do other searches? So here's an example of what search looks like for the query of 4K videos uploaded by Steve in January. And so this is our natural language search. So we do some extrapolation, like Steve is like short for Steve Hollyhead, and it knows that January in this case is the most recent January of 2026. So we currently have about 35 to 40 pieces of metadata for each asset that we put in our search index. This is an example of what some of those look like. What user is it assigned to, what's the bit rate, what's the resolution, et cetera. And then all of those have a separate like lexical process for putting them in the search index, in addition to the semantic portions. Excuse me. But trying to build a search UI that effectively and intuitively looks across 35 to 40 different kinds of metadata is cumbersome and complex and takes time. And so we opted initially to generate a structured OpenSearch query, because on the back end, not only is the UI difficult, but on the back end, creating the query from all of those different kinds of metadata is difficult too. So we have an LLM in the loop. So as a customer submits the query, we send it off to an LLM via Bedrock, and then that translates it into a structured OpenSearch query that we then execute against our search index. And then as we get feedback from customers around like commonly requested aspects to filter by, so like if someone's looking, I only want results in a specific project, then we can begin to add UI and API affordances for the things that customers actually want rather than trying to guess up front. Because we've got a strict and well-defined schema for our indexes, we are able to, like part of what we need to do is to get the LLM to not hallucinate fields that might exist. And so we inject our schema directly into the prompt so that it has a better shot of not hallucinating fields. It's not 100%, like LLMs are non-deterministic. So, and And one of the essential tasks that we have for that LLM is to discern what in the natural language query is based on the metadata filters that exist and what is coming from the semantic portions that are the list of floats in the search index. So the query that I showed earlier of 4K videos uploaded by Steve in January, that's entirely metadata. However, we can also search across those embeddings. So whether that's like you're looking for a photo of your dog wearing glasses, that's my dog, and he's wearing glasses. Or slow motion video of football players running up a hill. So these are all like real screenshots of video that showed up. Or if you want to do a more specific scene description of a female athlete on a track with a soft background and a lens flare, this is an example of like purely semantic query coming through. Those semantic query portions and the metadata portions can be combined. So if you're looking for photos of old people lifting weights, those are there. But if you need it to be more than 4 megabytes for whatever your campaign might be, you can restrict it there as well. So between the two, you can see we've got several senior folks, but not all of those are bigger than 4 megabytes. So those are the results. As you may imagine, this creates a very lengthy system prompt, particularly after we inject our index schema. The prompt has guidance around industry terms, how to distinguish between metadata and semantic queries. Our latest system prompt that can handle localized content is around 2,000 lines, excluding the injected schema. This is roughly what's in our 2.1.0 prompt. It's not prose, it's structured like a run book. So the model reads it from top to bottom, like here's what you're doing, here's how to output it as a specific query for OpenSearch, here's your decision tree, here's how you may boost specific fields that we want to rise to the top of the query. Here's the schema, what's the supported formats, et cetera, et cetera. It's a checklist, and so like each one of these sections that exist are basically related to production failures that we saw. So this has undergone quite a bit of evolution. So from our 2.02 index to our 2.1 index, this is several months like compressed into a single slide. What we found is like as we continued to add content to our prompt, the results got worse. And that's because it had grown and grown and grown, and there were lots of important things that the model needed to do in that ambiguous middle ground of the prompt, and so it took a lot of restructuring for us to do. That's why at the beginning we now have that decision tree. We have things like this is the single source of truth for this particular field, and everything is referenced by name and section number, and so we can cross-reference within the prompt itself, and that gives the LLM a better probability of finding the things that it needs to do for generating that query, which means that we don't have contradictions, and when we go to update things in the prompt, we only have one place to update it rather than several. So I want to pull out like a specific technique from that. That verification checklist at the end. So like every time that I found a prompt bug, I just didn't write a new instruction. I specifically added it to the end of the checklist of like, by the way, ensure that fields that are in must not are not in the highlight section, which if you're OpenSearch query people, like you will know what I'm talking about here. For like transcription IDs, those have to be in inner hits because it's a nested object, et cetera. So like each one of those was a past failure, and that checklist ends up being the part that I maintain most often. So this is an example of like one of those sections in there. So as I mentioned earlier, we recently added a bunch of localization so that you can search not only in your native language, but you can also search transcription content that are in different languages. So if a customer doesn't say like, hey, search for this content in the Japanese transcription or the German transcription or the Spanish transcription, it'll use the default language that the query is in. However, I didn't know this until a couple of months ago. Of the 3 specific scripts used for Japanese, one of them is shared contents with Chinese characters. And so if that's all you have, it's ambiguous whether you're doing a query in Japanese or in Chinese. And so in this particular case, we have the LLM search both transcriptions because it can't tell. So this ended up being the fix, this entire slide. So what was nice about this is like it wasn't code that needed to change. It was much faster to deploy. We didn't have to do any schema. We didn't have to do dual write and index migration. It was just from this. However, like because we can make changes to our prompt very fast, like we also need to have a regression suite that we can test all of the like natural language query things that we can do. Because you'd like to know if you broke something before a customer does. So I'll go into some of the lessons that we've learned. If there's a pattern in what this stuff is, it's that the tool tells you part of the story, but the work is actually noticing what's missing. So I alluded to this a minute ago, like as we've enhanced our schema over the last several months and our prompt, we needed to develop a suite of tools to automatically evaluate that. So quality of the OpenSearch query that's coming out is not the only measure for us because customers are waiting for search results and we need to generate the query from the LLM before we can execute the query. Latency is our primary metric that we're looking across, not just like how many tokens are in and out and for cost. So it is quality, like is it a query that can be executed? How fast can the LLM get us that query back? And then we worry about cost. So we get, like you're able to get all of those things from the Bedrock API. It's just a matter of using it. This is a screenshot from the initial model comparison that happened before I arrived on the team. It was at, it's very small, like I'm not expecting you to read it. But the point is like we have several queries that we had identified that may occur, and we looked across different models. And so here you can see like Llama 4 executed in like less than a second to generate this particular query. Sonnet was 6 times as long. And so we, in this particular case, like we can't wait 3.5 seconds for the model to generate the query for us to then execute. Like somebody's waiting for that to happen. And they're not going to wait 3.5 seconds. They're going to move on to something else. So in this case, like Llama 4 was our initial pick for which prompt to use. We're continuing to use it. Our regression suite has been primarily focused on did we break things in our prompt? But we will need to use a regression suite as we reevaluate models because the models move fast. Llama 4 is ancient, and eventually we're going to need to use a different model where we can potentially get much faster results back. Separating job management from our operational database, Noella gave a great talk around like Oban and its failures and a thing. I won't go into this anymore. Go watch her talk. It's fantastic. And she talks a lot about the failures that they had and how they recovered. So we need to upgrade our index schema and how we're calling those models. We needed to do many more updates to our schema than we initially anticipated. And so like this is the progression of our different index versions. And we had several periods of extended dual write to different indexes. So when we initially did this, we had no idea that we would churn through like 4 versions of our schema within the same amount of months. So if you're going to do something like this, like plan for needing to do a lot of changes to your schema as you get feedback. So the earlier snippet of the Broadway pipeline referenced this pipeline handler for function. This is the logic that's in there. So in this particular case, like we have different handlers for what's available within our particular index and what capabilities it supports, and then how we do that transcription processing. So I talked a bit earlier around like Japanese and Chinese things that show up in the index, and so with the 2.1 index, we're doing a different handling for transcriptions that come in than we were in the past. But those patterns both exist here. If you're wondering about this vegan embedding pipeline, I get a lot of nonsense internally at Adobe about this name. That is because the Adobe research model that was not trained on customer data is referred to internally by the research team as a vegan model because there's no content from customers. There are some customers that have opted in to using their data, and that's referred to internally as like the keto model. So that's not me. This is so that like I can understand exactly which model we're using from the search. So Broadway already gives you a lot of insight into the pipeline with its existing telemetry and metrics. With the LLMs being non-deterministic, we're constantly monitoring whether we're getting like a malformed OpenSearch query, how long it takes to generate that query, how long the query takes to execute, and how many results we get back. Because if we have a number of queries that return no results, that's another indicator that our query, even though it may be a valid OpenSearch query, is malformed. Because for most queries, we should get some results back. Broadway gives you a ton of telemetry for free, whether that's Broadway processor duration or processor message duration. You can just hook up your telemetry exporter like to Datadog with no code changes. For our particular like AI pipeline, that wasn't enough. It didn't tell us like if the upstream model was healthy. Is the LLM producing valid work? Are we wasting work? Nor what a bad day looked like. So I can show you some of what those things look like from production data. So this is 3 months of P50 and P95 processor durations for our embedding pipeline. Again, like I didn't write any code to get this. It comes straight out of Broadway. You just have to hook up your reporter. Yeah, so I talked earlier around what the max time is to generate embeddings. It's absurd that this axis for the max is in hours, but that's how it is. So like the P50, P95, and P99 are fine. Like the 99 is in minutes. That's okay. But we definitely like. You can see we had one a few weeks ago that was like 8 hours, but it is not uncommon for things to take 15 hours to do the semantic embedding. I don't know what customers upload. Like it's, very long videos, very complex videos. So, but this is also a reason like we couldn't necessarily like have Oban work on this. When you start to get jobs that are in the hours of execution, it's like, oh no, something's broken. Broadway is handling it just fine. We also have some SQS visibility timeouts. So if a job gets stuck or Broadway dies abnormally, like it'll get automatically retried. We are investigating if we can do some prompt caching. So given that we have a 2,000 line prompt, plus then our injected schema, our input to output ratio is about 90 to 1, because the schema coming out is relatively small. So there's probably some things that we can do here around reducing our costs with Bedrock. So again, like the tools will give you some data, like judgment exists in figuring out what that's actually telling you. Oban told us about jobs, but not necessarily the database load. Broadway tells us about the pipeline, but not our upstream results or where it's lagging. And the evaluation suite tells us about quality, but not necessarily cost or latency. So thank you, appreciate it. If working with systems of this scale sounds interesting to you, like we are hiring, we have most of our people remote throughout North America, but we do have a handful of remote folks in other locales like Spain, Germany, and New Zealand. So I'll go into questions.
Yeah, thank you, Jeff.
Either in the room. Thank you. Are there questions in the room or online?
Yeah, we already have the 2 questions online. And,
okay.
Or I can start with one of the questions online. So what kind of latencies do you have for the embedding times?
The question is what kind of embeddings what kind of latency do we have for the embedding time? So that's from here. So most of the embeddings happen within probably 30 seconds, less than a minute. There are definitely a lot of outliers and then our worst case.
Yep. Any more questions?
Over here.
Hey, I used Frame.io like 10 years ago, something like that. And I'm curious, was it translated to Elixir? Was it originally from Elixir? And what is the boundaries? Where is Elixir being used on Frame.io?
Yeah. So all of that predates me. I've been at Adobe and Frame for about 9 months. My understanding is that the very first versions of Frame.io were in Ruby, but they transitioned to Elixir, I think 5 or 6 years ago with the version 3 product. But that's not an authoritative answer. That's like my impression. There were other questions.
Sorry, like for the models, are you hosting them on the Elixir using BubbleBean and NX, or you have them on the SageMaker or something like that?
The semantic embedding models?
Yes.
Those are not hosted in Elixir. Those models are developed by our Adobe research partners.
Okay, so you contact via API or something?
We call them directly via an API, yeah.
Okay.
Yeah.
So you talked about like the quality, and you mentioned that you had to choose like how to measure it, right? Like you mentioned like the latency, that you guys chose like latency as like measurement of quality. So you could choose like the right LLM model for you.
Yeah,
here? Exactly. Yeah. That. Yeah. But like I wonder, do you guys like measure the quality of the results itself? And if you do, how do you measure that? Because at some point you mentioned that like once you leave like the prompt to the LLM, it might hallucinate, you don't know. But how do you measure like the quality? And also like when you get like an upgrade of the version, for example, how do you know if it's getting better or not, or it's getting worse? Or you don't care about that because like at this point latency is the only thing that matters?
Yeah, so the question there is how do we judge the quality of the query that's produced and the results of what comes back for that query? Yeah, so that's developed over time. So we have some people on our product side who have a very large sandbox where we know the content of all of the assets. There are tens of thousands of assets, and as we have like these queries that are on the left, we know which specific assets ought to be returned for those things, and so we can then do an automatic evaluation of those queries and their execution. So part of the regression suite is not only like generating these queries, but then starting to execute them against that particular test data set and evaluating what's coming back. And so we did this also as we were localizing all of our search. So we had to do like initially machine translation of these queries into German, into Japanese, and then execute those things and then look at the results that came back and say like, oh, we're not getting the results back for Japanese that we would anticipate. Like, is it the query because we did machine translation, or is there something wrong like in our code? I think there are a couple over here, yeah.
Hi, thank you for the talk, Jeff. I was wondering, since you were talking about how the system prompt came bigger and it was a problem, have you experimented with splitting that prompt into multiple LLM calls, like in phases or steps?
We had thought about that, right? So whether we have like The Bedrock API is a converse API, and it is intended that you go back and forth and get results and ask more questions. And because we're very latency sensitive, we didn't want to send the request off, process the results, then do a further evaluation and send more information. So we're trying to like one-shot it as much as we can, mostly for latency.
So you've got this long tail of occasional jobs that take multiple hours before they finish successfully. How do you tell the difference between a job that will finish successfully in 8 hours' time and a job that's stuck or deadlocked and will never finish?
Yeah, so that's a good question.
Or do you, in fact, have a few jobs in your system that have just been running since last September?
We do not. So the upstream service, if it encounters errors while it's processing, it will cancel out. And so it is, I suppose, possible that like we're waiting on jobs that would never finish. We do have some cases where we just will fail a job if it retries a bunch of times, then it goes to a DLQ.
But this is also an endorsement of Broadway's error classifier.
Yeah. And I have some of those things. They're not in the talk, and so like if you want to see our Datadog dashboards, like afterwards, I'm happy to show you what we've got. And I think, Vasilis, you said there was an additional question online too? Or did we answer all of the online questions?
Yeah, I will read it after this one.
Okay, great.
Thank you. So I was wondering whether you do anything related to the structure of the embeddings themselves, especially for like needle in the haystack, or like the difference between, I guess, a frame embedding and what a whole video means, and whether you do any separation between the two.
Yeah, so from our internal model, we do get additional information, like what kind of scene it is, whether it's like a close-up, a wide shot, and then we do some clustering around like different scenes. So if it's a very long video that's like a basically static shot, that gets condensed down into like one embedding, and that's mostly the purview of our upstream Adobe research folks.
And so we actually have 2 questions online from Grigory. First, he wants to thank you for the talk, and he asks, what LM provider and model are you using to get the prompt, the query from the prompt?
Yeah, so we're using Llama 4 on Bedrock.
Yeah. And then could you share some details on OpenSearch cluster architecture, sharding, like things like sharding, routing, sizing, and the search engine tuning?
Yes, but probably not in the like 1 minute that we have left. So we are very shortly migrating to a cell architecture for our stuff within OpenSearch, so that we can have specific things that we're targeting for enterprise customers who may need their data segregated or may need to bring their own embeddings, et cetera.
Thank you. Yeah. All right, we have time for one more question.
Hello. How many queries that like you receive from the users and you successfully parse to valid OpenSearch queries? Like, do you still have invalid queries that are produced? What is the acceptable rate of like semantic queries that don't like go to OpenSearch and like return you 500? And how was the progress over time? Like, do you start with like 90% and then you progress to 90 something? And what is the acceptable rate for like queries that can go wrong basically and are not something OpenSearch can answer?
Yeah, so this is the last several months of that traffic for our Bedrock invocations, so the number of queries that are occurring. So it gets up into the nearly 10,000 queries an hour. Yeah, so the question is like how many of those end up being wrong queries. We've gotten that down to very small number are broken. We still are just like outright broken as queries. We still have a number that come back with 0 results, and that's a very difficult thing for us to discern, like, is it the customer searching for a thing that actually has no results in their particular account, or is it the query? So we'll spot check a few of those, particularly as we've upgraded our prompt. Yeah, does that answer your question? Great.
Yeah, actually I see we have a lot of questions, so if that's okay with you, Jeff, we can do another 1 or 2.
Sure.
Okay. All right.
Yeah.
Hi, thanks for the talk. Quick question. I saw the example queries of for OpenSearch, but I didn't see like the KNN. So it does a full text search only, or also hybrid search?
So the question is, for the semantic, are we doing KNN, or for like metadata, are we just doing?
No, for the part that Llama generates. That's only, if it is only metadata, I guess it doesn't have semantic search embeddings. I'm looking for do you use hybrid search that OpenSearch supports since like 5 or 6 months ago, or maybe more. But do you use that feature of OpenSearch or no?
Yeah, so we do use the KNN features of OpenSearch in our queries. What we get out of Llama is a scaffolding for that query. We'll do some enrichment of the query to get the embedding. So for the examples that we showed earlier of like my dog wearing glasses, the query that we get back from Llama is a scaffold of that. And then we call out to SearchCut to get the actual embeddings for that particular description of the scene, and then we do a KNN query within OpenSearch for that particular embedding. Yeah.
All right, and our last question.
Okay.
Yeah. First of all, thank you for the talk. It's really nice to see a production example. I was wondering, like you mentioned, how you upgrade your indexes, and I was wondering, how do you do that in terms of the dual write approach that you briefly mentioned? Like in terms of, do you start a new process in Elixir to kind of do that? How do you manage that ongoing migration of indexes?
Yeah. So on the forward fill, all of our incoming pipelines are able to do dual write between the production index, the main index, and the pending index that will become the new one. On the backfill, it depends on what kind of backfill it is. So in some cases, we can migrate directly across from the prior index, and in that case, we use OpenSearch tools to facilitate that. There are other cases where it's been a more complex change to the schema, and we've had to like spin up our own like jobs that may execute for just like one-off migration types of things. It's as the situation dictates. So.
All right. Thank you, everyone.
Thank you. Appreciate it.